solving inequalities with the word or. Let's take a look at a typical inequality that includes the word or. Here's an example of a problem that you may see on your homework. Find all values of x which satisfy the following statements. X is less than negative 3, or x is greater than or equal to 5. Well, before we write the solution in interval notation, let's take a look at the number line. So let me draw a number line. I'll just put a reference point of 0 here so I see what I'm doing. Let's see, here's minus 3. We don't need to be exact. Yeah, that looks to be about 5. Now let's go ahead and sketch this portion of this inequality on the number line. It says we want the values of x that are strictly less than negative 3. And if we remember, we need a open parenthesis on the negative 3 to represent that x cannot equal a negative 3. And we want the x's less than negative 3, so we would graph or draw a line to the left with an arrow. Okay. Similar, we want the solution of all x's that are greater than or equal to 5. So that equal sign means I need a closed bracket on the 5. And I need all the x's that are greater than or equal to 5, which means I need to go to the right of 5. So there's the solution on a number line. Now, typically what we want to do is get the solution into interval notation. So this is where the word or comes in. Remember when we did the and inequalities, the and meant both, okay? We needed both at the same time. Well, the or is a little different. What the or means is union, or we can think of the word maybe combining. So let's take a look what I mean by that. I need all of the points x less than 3 union with or combined with the points of all x greater than or equal to 5. And the way we write that is simply we write down both intervals. There are all the points that are less than 3. And what we're going to do in place of the or, we're going to draw this symbol right there. Looks like a horseshoe. This is the union symbol. Okay? I'll write that down. That's the symbol for union in mathematics. Well, we also need to put this interval, close bracket 5 to infinity. So, let me read this statement here. This means the set of all points negative infinity to negative 3 union or also or combined with the points from 5 to infinity. Okay, so that's a typical or inequality. Let's do a couple more examples. All right. X plus 1 greater than 3 or 2x minus 1 less than or equal to negative 4. What we want to do is we want to solve both of the inequalities for x, which means let's get x on one side of the inequality. So this one looks fairly easy. I'll just solve this one by subtracting 1 from both sides. And remember, when I subtract, I do not change the direction of the inequality. So I need to subtract 1 here. So I get x greater than 2. Okay. Now I will independently solve this one as well. Let's start by adding 1 to both sides. 2x less than or equal to negative 3. Now divide by 2. And I get x less than or equal to negative 3 halves. So there's my two inequalities. And what I'm basically going to do is just bring down the word or. Now, I want the points of all x that are greater than 2 combined with the points of all x that are less than or equal to negative 3 halves. And again, what I'm going to choose to do is draw this first on the number line, and then we will get the interval notation. So here's my number line. Again, I'll just put a little reference of 0 there. Let's say that's the number 2, and maybe this is the number negative 3 halves. Okay. So let's go ahead and sketch this one. We need all x's greater than 2, so that's an open parenthesis, and to the right. X less than or equal to negative 3/2, so that's going to be a closed bracket. And I need x's to be less than this, so I need to go to the left. Okay. And so there's my solution set in graphic form. Now I'll simply write the intervals. This interval is negative infinity to negative 3/2, closed. And remember, in place of the word or, when we write in interval notation, I'll use the union symbol. So I need all of these points, union with all of these points, to infinity. Okay, let's try one more example. Okay, my variable is b this time, that's fine. Again, I have an or statement. And again, what I'm going to do is I'm going to solve each of these inequalities independently of each other, and then I'll graph the solution on a number line, and then I'll come up with the interval notation. So let's solve this one first. I'll add 3 to both sides. 2b is less than or equal to 8. Divide by 2. b is less than or equal to 4. And I'll put a little box around that to represent that we're done with that one. Now I'll go ahead and solve this one. Why don't we subtract 1 from both sides? Negative 3b less than 6. Now we want to solve for b, so I'll divide both sides by negative 3. Remember, when I'm dividing or multiplying by a negative value, I must invert or switch the direction of the inequality. So this one becomes a greater than. And again, I'll bring down the word or. So we need all points that are less than or equal to 4 combined with all the points that are greater than negative 2. Again, let's see what that looks like on a number line. And we don't have to be real accurate with our scale here, as long as we have the negative 2 on the left side of 0 and the 4 on the right, and so on. Let's see. Let's plot these points first. B less than or equal to 4. Well, remember, the equal sign gives me the square bracket. Less than means I need to go to the left. So I need all of those points. Now we'll go ahead and do this portion. B greater than negative 2. So I need the open parenthesis on the negative 2. And I need to go to the right because it's greater than. Now, remember, or means combined with, or union. So I need all the points less than or equal to 4. I also need all the points greater than or equal to, or strictly greater than negative 2. And notice what happens. When I combine all of the points, I get the whole number line. So we might have to ask ourselves, well, what's the interval notation? Well, the whole number line is simply going to be from negative infinity all the way to infinity. So the solution is all real numbers for this case. Okay, you might want to practice a couple of these. You may want to go back and review the AND portion of the inequalities and see what the difference is. Remember, AND means we need to take the common points. OR means we need to take both sets of points.